Well, good afternoon, all. My name is David Harrison, and a little bit of my background is I was in the cable communications industry for about 37 years, and before retiring from Charter last in June 2022. And I've had the opportunity to work all over the world in this great industry that we call cable. And more recently, as I've been residing here in Colorado, where I've been on the board and supporting the Rocky Mountain SCTE since 2019. So it is a great pleasure for me to introduce you today to Flavio Marcon from CPAT Flex, and he's going to talk to us about the wonders of ingress and egress. And in today's presentation, he'll be focusing on the needs for preventative maintenance and highlighting some of the similarities, but also a number of the differences between egress and ingress issues on the network. Before I do that, I'm going to just talk a little bit about our mission here, specifically at the SCTE Rocky Mountain chapter. But I would firstly like to thank all those members that have joined today from both the Great Lakes and Rocky Mountain chapters, and for supporting the SCTE. It is really rewarding for us to know the events we provide are valued, as we value your membership. Key areas around our mission are education, which lets us provide to you as members many, more than hundreds of training opportunities and boot camps, most of which are provided free to members. We also allow for advancement in your study and career through certification, and developing those technology professionals within the industry. We also focus on standards, and we have accredited programs, particularly like from ANSI, regarding next generation video technology and distributed architecture, and along with our collaborators at the Cable Labs, standards is a key part of the SCTE mantra. Career advancement I mentioned briefly, and we're really focused on helping our members develop their career goals through mentoring and professional development opportunities, as well as certification. We also offer a number of networking opportunities and several live in-person events throughout the calendar to create really good networking opportunities for our members, as well as within the vendor communities and our sponsors. Technology and innovation, again with our partnership with Cable Labs, the latest technology is available to us, at our fingertips, if you like, through our organization, and we can put that in the hands of our members firsthand. Community outreach, we're doing a number of programs with local schools and universities, and we've been supporting a number of robotics teams over the last few years, as well as sponsorships for those wishing to pursue an education in the technology field. Next slide, thank you. So if you're not a member of the SCTE, please consider joining membership with us. And there are a number of key benefits, some of which we've already touched on, such as free training, like the one today, for example, and as well as the opportunity to meet experts and other members of the our organization that available for sponsorship, for mentoring, and as well as providing some of this training. Comcast and Charter both cover the cost of becoming members in the SCTE in two different ways. There is a QR code for Comcast specifically through their program, but Charter also does reimburse members for their membership. Next slide, Travis. Certifications I've touched on, but here you can see that we do have an end-to-end coverage of certifications within our programs, everything from engineers through head end, out through the network, right out to the customer installer and service technician. So whatever field you are in, we have opportunities for certification and helping to build your career profile. Next one, Travis. Thank you. Yep, as mentioned, it can improve your cable knowledge. You gain recognition in some skill sets, as well as increasing your hands-on skills and hopefully the ability to advance your career. The incentive program we run here, the chapter reimburses for out-of-pocket expenses, as well as we have a incentive reward per certificate. So if you are successful in completing the certification and complete the exam fee will be reimbursed, as well as obviously any other out-of-pocket expense, and we provide an incentive reward. And on the next page, there's a few examples of what those might look like. I'm not going to go through them all, but obviously you can work through some of these and attain multiple certifications. So it's not limited to the number that you can do. You're not limited on the number that you can participate in. Something to keep in mind, save the date. Those of us that are in Denver are fortunate enough to have the SCTE returning here. And apparently it's the first time since 2017. And I was surprised when I saw that number. Yeah, I guess time really does fly. It seems just like yesterday that we had the last expo here in Denver. So please, if you are in town, make an effort to get down there, and the Rocky Mountain SCTE will be on hand to help facilitate. And I personally am going to be helping out the SCTE on I think giving out the gift bags and things. So yeah, look for me on Tuesday to come down. Next slide. And also, obviously, in the age of social media, so please connect with us on social media platforms. We're covered on all the main platforms you see here, as well as we do have, I think, a LinkedIn site as well. And then on to industry partnership. Yes, not to forget the critical role that our partners play in supporting our chapter organizations throughout the country. And we're particularly in Rocky Mountain grateful to Charter and to Comcast and Vecima for being our top industry partners this year. And we have a wide range of other vendor partners and other organizations such as NCTI that are partnering with us here in Colorado to provide the types of meetings and training and services that we provide to our members. So thank you very much all all of the partners that we have supporting us. And with that, I will hand over to Flavio Marcon from CPAP Flex, and he can provide his 35 years of experience in talking about the intricacies of egress and ingress characteristics, both common and also unique. So take it away, Flavio.
Well, thank you very much, everybody, for joining this afternoon or this evening, depending on where you are, to assist at this presentation of the Rocky Mountain chapter of the SCTE. So what we were talking about today, I want to cover the aspects of noise mitigation and the fact of, fixing all your ingress or egress rather, and if it will also eliminate your ingress problems. All right. So getting back to the presentation. So as I was saying, in today's broadband cable networks, are transporting signals that are significantly impacted by the health of the cable plant's condition. So preventive network maintenance of these networks is very crucial in keeping efforts in order to keep the coaxial plant operating well, optimally, and delivering, of course, a very positive client experience, which is, of course, the source of revenues of all the cable companies. So what I wanted to say is that, while you're performing egress or leakage detection operation, that are very essential in maintaining a reliable cable system, as well, of course, as you know, to adhere to FCC rules, okay, it may not actually resolve all your ingress-induced noise issue, okay? So even although egress and ingress issues could have some similar causes, okay, there are nonetheless some significant differences as to what causes each, okay, and we'll be exploring some of these points here. So fixing my ingress problems will also fix my egress problem. Not necessarily, okay? And I've been around on several occasions in the field with technicians, okay? And there is a kind of a general perception, okay, that by doing your routine writing out for leakage issues, okay, it will correct all your noise impairment problems, okay. That's not necessarily true, okay. Although leakage repairs activities are necessary for plant maintenance, okay, it will not ensure a complete plant health, okay. So ingress hunting is definitely a necessary evil to do, okay. And of course, it is a little bit more difficult to hunt for egress than it is for ingress rather than egress itself, okay. It all depends, on the different types of flaws, physical flaws that the coax cable, okay, plant has sustained, okay, and of course, how the shielding integrity is effective, okay. The signals, okay, on the plant will propagate differently. The first thing is to realize, of course, that there is some correlation, okay, but there is little correlation between leakage fuel strengths and actual ingress levels, okay. If there's any correlation in frequency, okay, for leakage, okay, it will mostly be present in the higher frequencies as opposed to the lower frequencies, or what we commonly call the aeronautical frequencies. Okay, in a lot of situations, okay, you may find that you have an ingress issue, okay, or what I call a penetration point, if you want, okay, of noise getting into the plant, okay, because of a flaw in the cable, okay. But you may also see, okay, that if you're also doing high frequency leakage, okay, in the 600 to 800 megahertz range, for example, you may also have a leak present at that same location, okay. And this is not necessarily true, okay, when it comes to the lower aeronautical frequencies, okay. On this next slide, I want to show you an example, okay, of a study that we had done a while back, okay, where we had a cable system location, okay, ridden out, okay, and the total mileage ridden out by all the vehicles that were doing this test, okay, obviously was during their routine work, okay, it was about 18,000 miles of ridden plant, okay, and this was over, if I remember correctly, it was over about a 3-month period, okay. So after all this driving out, okay, we compiled all the data, okay, that we had gotten from the the patrolling that was done, okay. And what we were doing, of course, is we were doing mid-band aeronautical frequency leakage detection, as well as LT frequency detection in the higher frequencies. And if my memory serves me right, it's around the 714 megahertz range, okay. So we compiled this, okay, and we took and we derived, okay, this chart showing the differences in the types, okay, of events. And when we say we commonly call these events, okay, whether it's a leakage event or an ingress event, and as you can see, okay, starting with ingress only. So this is actual events, okay, that were found in the plant, okay, that did not have any leakage whatsoever present at those flaws in the plant, okay. So we see that out of all these events here, 25%, which is a quarter, which is pretty significant, okay, was ingress only, okay. Now, what is interesting to notice as well is that, you know, the LTE leakage portion of it, okay, was also significant, okay, which is very typical, okay. If riding out a plant and doing both mid-band and leakage and LTE leakage, okay, typically, okay, we expect to have at least a 4-to-1 ratio of a high frequency versus aeronautical frequency. But what's also interesting to note here, okay, is that even though we did ingress and LT leakage, only 25%, okay, of these events as well, okay, had experienced a co-located event. In other words, it was an LT leak as well as an ingress point, okay. And what is very, very important to note in this case here, in this whole chart, okay, is that the overall mid-band only and mid-band mixed co-located leaks that were present during this ride-out. So we see that when it concerns mid-band, okay, there was only about 16% of the total events that were recorded during this ride-out. Okay, so this is an example to prove, okay, that there are importances in doing ingress detection, okay, or locating, okay, as well as also doing LT leakage, okay. There are still some plants, okay, that I'm familiar with that are, you know, just in order to respect FCC regulations, okay, are just doing aeronautical leakage detection. Okay, well, this actually also shows, okay, that just doing aeronautical detection is not sufficient, okay, to be, you know, to try to cover all your noise-induced sources that are coming into the plant. So next, what I want to do is I want to say, let's discover what ingress is and what egress is and what are their physical differences, because there are physical differences, okay, that will cause a leak in a coaxial plant as opposed to noise being introduced into the plant, okay, which we call ingress. So definition, what is ingress? Well, it's very simple, okay? It's an over-the-air signals that are inadvertently, okay, coupled, and this is important to remember the word coupled, into the nominally closed coaxial cable system, okay? Basically, okay, it's unwanted noise, okay, that is coupled onto the plant, okay, and therefore eventually will penetrate the plant, okay? The causes, of course, as you all know, I'm sure a lot of you have seen loose connectors, okay, corroded connectors, cables that are damaged, or even poor quality connectors or passive devices in the homes. Now, this is important because the chart that you see there from some data that also has been compiled, okay, is that 70%, okay, of the sources of ingress, okay, are from the home, okay. We're not saying that there's 70% of the ingress points that are in the home from the homes, okay. We're saying that there's 70% of the causes, okay, of ingress, okay, that are coming from the actual home itself, okay. 25% of them, of course, are the drops, okay, which are exposed, okay, and of course the surprisingly only 5% of all these problems come from the actual plant itself, the feeder plant or distribution plant. So on this next slide, we're going to take a look at, we're going to see what is ingress in an electrical environment. So what is a coaxial plant? Okay, well, essentially it's a 75 ohm balanced circuit. Okay, so whether the ingress occurs, okay, is the external signal, okay, or noise, okay, is coupled, there goes that word again, is coupled onto the outer surface of the coaxial cable shielding, okay. When this happens, okay, it generates what we call a common mode current. And this current will propagate, okay, along the outer surface of the cable shielding and also all the support strand, okay, or the that is supporting the cable, okay. It will travel on there, okay. So when there is a common mode current and it reaches a shielding integrity issue, in other words, the actual flaw in the coaxial plant, okay, it then creates a differential mode current, okay, and this will then start affecting the actual signals inside the plant, okay. So this is, if you want a resume in an electrical format, okay, of what happens when ingress occurs. Okay, so and this is also not necessarily, okay, the conditions, okay, that will create egress or leak in the plant. Okay, now on this next slide here, okay, I want to give you a representation, okay, of leakage and how it's regenerated. So essentially, when there's leakage in a coaxial cable plant, okay, there is a condition that affected the coax plant, okay, or the cable mostly, okay, that will create an antenna effect, okay. So what I'm showing you there on the screen, okay, and it may be a little difficult to see, okay, but this is actually a purposely leaking cable, or it's called a radiating coax cable, okay, also called a leaky feeder. Okay, now this type of cable, okay, is for it's essentially for broadcast communications, okay, and it works in a 50 ohm environment. Okay, it's typically used in environments such as such as tunnels, subways, or even in mining applications. Okay, so what you're seeing there, although it's 50 ohm, the principle of a coax cable is the same. Okay, so what you're seeing here is you're seeing the coax plant, the coax cable, the conductor, the dielectric, and the shielding. Okay, now in order to make this coax cable radiate energy, okay, um, you introduce, what they do is they introduce some apertures, okay, along the shielding, okay. Now these apertures, okay, will vary in space between the apertures and in size depending on the frequency required to be transmitted or broadcast from the radiating coax. Okay, so essentially, this is the same principle that happens in our coaxial networks. Okay, when there is a condition that there's a physical flaw, okay, being a ring crack or a loose faceplate on the tap or something, it creates a condition, okay, that simulates an antenna, and therefore the signal will be irradiated from the plant, okay, and therefore what we call commonly a leak. Okay, now you also notice that in this particular condition, there's also ingress that comes into the cable, okay, which is a fact, okay, at wherever there is a leakage event or leakage problem, okay, you'll also have ingress at that frequency, at that same frequency, okay. However, the magnitude, okay, between the two, okay, is going to be substantially different. Sources of ingress again. Well, there's lots of sources. I mean, they're all around us. There's all kinds of frequency or noise sources, okay, that can impact the plant, the cable plant, which should be a completely hermetically closed plant. Okay, so home appliances, microwaves, hair dryers, all kinds of devices, okay, cell phones, of course, which is lots of those, okay, all kinds of devices create noise. Okay, so this noise is in it's in the ambience, it's in the air. Okay, you also have all kinds of off-air signals, either from radio, AM, FM radio, from television, from aeronautical communications, CB radios, and all kinds of wireless devices. Okay, so there is a multitude, okay, of noise, okay, that is present in the air. Okay, and therefore all this noise, okay, if it finds its way into a coaxial plant, okay, well, it will obviously impact the services that we provide. Okay, I show you some examples that we're looking at there of what are causes, okay, of ingress. Okay, so as you can see, corrosion is or a corroded or loose heft connector, okay, is a very pertinent problem, okay, since this type of device or this type of apparatus is outdoors. Okay, so corrosion is a very important cause of ingress. Okay, we have as well, rubbing damage, okay, when the coax plant, okay, is rubbing against whatever, either a tree or some other kind of object, okay, and where the outer shield and the shielding itself, okay, gets rubbed away, okay, and therefore creating a situation, okay, where the cable shielding, okay, is impacted. Okay, and of course, you have rodent chews or rat chews, squirrel chews, what have you, animals that chew into the cable plant. Okay, some other type of causes, okay, of ingress, okay, are what you see there. Okay, a kinked cable. Okay, even though it is not exposed or open, a kinked cable, okay, will be a definite source of ingress. Okay, as well as on the little left there, a little coaxial drop cable there that has been just rubbed just a bit, where the shielding was partially broken. Okay, hard to say there, but the dielectric was also a little impacted as well. Okay, which becomes a perfect spot, okay, for all this ambient noise that we have to enter the plant. This next slide also shows some other different examples, okay, experienced by myself, okay, where you see on the right-hand picture there, you see actually a cable that is lightly kinked. It doesn't look like it's severely kinked, but it actually was. In the little center picture there, we see the actual fold, okay, in the coaxial cable, and we see that the shield and the dielectric in the very center there was squeezed into the coaxial cable, therefore causing again a great a great place for noise, ambient noise, to penetrate into the plant. And of course, rodent shoes again. And lastly, okay, one of the points is, unterminated subscriber outlets. Okay, and this is particularly, okay, something that is very common recently, in the recent years, okay, where a lot of cable operators, okay, have decided to do soft disconnects and not actually disconnect the house from the plant, and therefore leaving all the plant within the home, okay, whether it's connected to the plant or whether it's connected to a cable subscriber or not, okay. But what happens is all the noise that's generated in the homes, okay, as I mentioned before, now has a gateway into the plant, okay. Now, out of the 3 slides I showed you, one common thing I can assure you, one common thing, okay, with all these events there, okay, is there was never a leak, okay, in any of the conditions we just covered, okay, whether it be the rodent shoe, the rat shoe, the kink cables, okay, or the corroded cables, okay. Those areas had all been patrolled, okay, ridden out, okay, with leakage detection, and there was never any leaks detected whatsoever. Okay, so again, a very good example, okay, how there's a substantial difference, okay, in ingress and egress. Now, what I want to show you now is an actual experience, okay, that we did not a little while ago, okay. So what you're looking there, okay, is it's about a 1.5 mile of cable run, okay. It's 412 cable, and what you're seeing there, okay, is a all those little triangles, okay, that you're seeing there, okay, are actually ingress points, okay. That you may be saying, well, if there's an ingress point at every one of these triangles, okay, that whole cable strand is in pretty bad shape, okay. Well, one of the things about cable, remember, about ingress, remember, is that it it propagates, okay, on the strand and on the shielding, okay. So at each of those locations where there's a triangle, okay, there's an ingress reading that was made, but there was not necessarily an ingress problem at that point there, okay. But what you can see is a pattern, okay. As you're going from the top to the bottom, you see that the triangles, okay, have a beige, brownish color, okay, and then they become red, okay. Well, this in the legend, okay, would show you that what's happening here is that the signal level of the ingress that was measured was getting higher, okay, as we approach the actual flaw, okay. And if you look past that little symbol where you see a square and a circle, you see again, you'll have 2 red triangles indicating some pretty substantial ingress level measurements, okay, and then it goes away. And then we have some triangles there, okay, which are in red, okay, indicating a certain high level of ingress. And then further down, you'll see that it goes down to a beige colored point, and then a green color, which indicates, okay, it's decreasing in value. Okay, so what this shows us, okay, is that two things. First of all, we have to keep in mind that ingress does travel on the strand, okay, and you do have to use some logical approach in order to be able to find the actual ingress point, okay. So what we did here is we drove this plant back and forth, okay, and we were using the Ingress, an Ingress detection system, and just doing mid-band error leakage. Okay, so what you're seeing there, the spot where there is a square and a circle, okay, that is a location where there was a co-located ingress point and leak. Okay, the only thing to mention though, however severe this ingress problem was, okay, that leak there that was recorded was only 20 microvolts. Okay, so you can see that this was very severe, okay, causing, you know, the a small amount of leak to be radiated from the plant itself. So what did we find? Well, that whole problem, okay, was caused by two situations, okay. That mid-band leak and co-located with ingress, okay, was a 412 splice, okay, where the center conductor, okay, was actually severed, okay. Surprising that that happened, but I tried to take a picture and show it, but it was actually severed, okay. So it was not a completely broken connection, okay. It was barely rubbing against each other, but okay, it was still conducting the signal, okay. However, a lot of noise was getting into the plant itself. And the second problem that was found, okay, was a corroded connector, a very simple RG6, this was RG11 cable, okay, that was ran across the road down the pole, and the splice, the ground block, was on the pole itself, but it was with the with the cable flowing down into the connector. So a perfect way, you know, for moisture and water to seep into the connector. Okay, so once we found these two problems, okay, we wrote again the plant, okay, and there you go, everything is gone. Okay, so what we did is we fixed the problem with the splice where the other where the square and the circle symbol was, okay, and we eliminated the majority, okay, of all the ingress problems that we had located initially. You see there was still a couple of little ingress points there that were left over. That was probably another problem that we didn't have time to fix. Okay, but what I want to demonstrate here, okay, is that just doing leakage, which is exactly what this company was doing. Okay, they were continually going out to this location, okay, and driving through this area here looking for leaks. And unfortunately, they were only using an aeronautical leakage frequency and not an LTE. Having had the LTE, they may have found it earlier. Okay, but nevertheless, okay, this took about, I would say 1 hour in all, okay, to fix these problems, to find and to fix these problems. And previous to this, okay, the customers in the area were affected by it, okay, and they calculated, or they not calculated, but they found data in their customer service software where there were 38 service calls, okay, that were generated within the addresses within that area there, okay, proving again this is a very expensive, okay, repair, or very expensive problem, okay, and one that probably frustrated customers quite a bit. Okay, so again, very important, okay, to do ingress detection as well as leakage. So ingress detection. So there's different ways of doing it. Okay, this is of course the traditional way, okay, that we've been doing for many years, where we call it return path monitoring. Okay, where you have essentially a switch spectrum analyzer at the head end. Okay, going through multiplex switches and looking at all the nodes individually. Okay, and when a high signal to noise or a high noise level is located from one of the nodes, okay, then we know that within that node, okay, there are some ingress issues that need to be addressed, okay. And in this, of course, in this fashion here, what you would do in normal circumstances is go out and use the old divide and conquer technique, okay, to be able to isolate, okay, where the ingress is coming from. This next slide here shows you, a little progress that we did over the last few years, and now we're using PNM, okay, ingress detecting or locating, okay, in where the cable modems from the subscribers, okay, are actually providing a view, okay, and of the return path, okay, coming back from each of the spectrum from the cable modems, okay, and therefore allowing you to isolate, okay, a sector in the node, okay, that is causing that is a source of ingress that's causing ingress. So in this situation here, well, is then you have to go out to the actual sector itself, and you still have to use some divide and conquering techniques in order to locate the problem accurately. So the last method that we can use to use ingress, okay, is geolocating the ingress points, okay. So having a vehicle, okay, that is equipped with a ingress transmitter, okay, you're able to drive in the node, okay, which was signaled, okay, as having by PNM, okay, which was shown by PNM to have, okay, some ingress or noise problems, okay. So the vehicle can just go out in the actual area, the sector or the node, okay, and drive it out, okay, and by using geolocating ingress detection, okay, you're actually able to almost pinpoint, okay, the actual fault on the coaxial plant. Okay, so this method, of course, is a lot faster, a lot more effective, okay, and allows you to resolve the problems of looking for ingress and repairing them in a more timely manner. So as we were saying before, where does ingress originate? Well, the homes, for the most part, that's where the noise comes from, okay? The plant in the home as well, that's very important, okay? A lot of times the plant in the home itself is not in good shape, okay? And the subscriber's home plant is essentially outside the control of the cable operator, okay? So you're essentially connecting your subscriber to your plant, okay, with a subscriber cabling, okay, which is not necessarily up to par, okay, requiring you to, of course, do some inspections inside the home to ensure that that cable plant inside the home is actually resilient or and hermetically sealed, okay, to ingress. So here's a little example. Of course, we can do just a walkthrough into the home with an ingress detector, okay, and be able to pinpoint if there's any ingress points, okay, that are in the home itself. All right. So shielding integrity it's just the secret of keeping signals in and the noise out. That's what we need to do, okay. And why ingress and egress mediation? Well, of course, egress is required for FCC, okay, but also it is required, okay, for plant health and in order to keep plant performance up to par with the new technologies that are being provided these days, okay. Customer experience also is very, very important, okay. They are the bread and butter of the industry, so we are making, we are earning our revenues based on our subscribers, so we need to take good care of them. You're, of course, by doing this type of preventative work, okay, you're going to be lowering your operating costs, okay. And it also, it's all around, okay? It's a very important idea to promote, okay? And to keep doing egress leakage detection, of course, but mainly, okay, to concentrate and work as much as possible on your ingress problems in the plant. And that wraps up this little presentation. And if there are any questions, I think we could open for questions.
Yep, and if anybody does have questions, feel free to drop them into the chat. I'm keeping an eye on it right now, and we'll see if any come in. Okay, Flavio, I'm not seeing any come in right now, but I do just want to mention when you were
Yep.
showing all those different examples of
Yes.
the issues that you were finding in the field,
Yep.
I thought you were, going to be talking about what percentage were, ingress versus egress and kind of draw it back to that pie chart you talked about earlier. And then when you dropped the bomb and you were like, yeah, none of these were leaking. I was like, wow, okay, that's an eye opener for sure.
Yeah,
That's impressive.
definitely. Definitely.
Yeah.
These are the examples that I've collected over time that to prove the point, and surprising myself as well as I witnessed it in person where there was absolutely no leaks in any of these in any of those causes there.
Yep. Yep. And we do have a question that came in.
Sure.
Question is, have you done any leakage and ingress testing above 1 gigahertz?
Haha, not yet.
Okay.
Not yet, and that I'm sure is going to be a very interesting challenge, to say the
I
least.
bet. Yeah. Yeah.
Yes, the plans going up to 1.2 gig or 1.8 gig, yeah, it will be quite interesting to see what kind of effect, okay, we'll be seeing with leakage and ingress, okay, up in those much higher frequencies.
That's a good point because now you might find eventually new or different sources than what we've had before as well, right?
That's correct. That's correct.
Interesting.
Very, very smaller wavelengths. So, this my 4-to-1 ratio of LTE versus midband. Well, curious to see what kind of ratio we're going to see between, 1.8 gig and midband.
Yeah, that's a good point.
Yeah,
It'll be things we haven't even thought of yet, I imagine.
absolutely, absolutely. That will be a new frontier.
Hmm. Okay. Not seeing any additional questions coming in, but definitely want to say thank you very much, Flavio, for your time today and for running through your presentation today.
Well, it's been my pleasure, and I hope the information that I provided is going to help all the attendees, or in their day-to-day work, and see and the way they approach ingress versus egress, which was the important point in this presentation.
Oh, I did just have one more pop up.
Yep. Right.
Okay, you still have a minute? Awesome.
Sure, sure, absolutely.
Okay. How about your thoughts on using a near field probe to track down a leakage source in, say, a cabinet full of equipment or splices?
Well, a near field probe, as far as being used in the cabinet for detecting leaks, okay, is definitely an advantage. Okay. Generally, leakage detectors we use per se use monopolar or omnidirectional antennas. Okay, making it hard to pinpoint in situations like that.
Mhm.
Okay. However, in the case of ingress, which is a good point you bring up, in the case of ingress, okay, that too, okay, it's how would I say, it's a lot simpler. In fact, okay, looking for a flaw in a cabinet related to ingress, okay, as opposed to leakage. So with an ingress transmitter, okay, you probably be able to immediately find the source of the problem. With a detector meter with a non-directional antenna, well, that's going to be a little more complicated. You're going to have to do a lot more, how do you say, meddling through the cable in the cabinet. So yeah, definitely a directional near field probe, okay, is a very good advantage.
Good point. Thank you. Okay. I think that really was the last one. So again, Flavio, thank you very much for your time today, and I hope you have a great evening.
Well, thank you very much. Thank you to all, and I hope you all have a great evening as well. And hopefully see a lot of you at the Cable-Tec in Denver.
Awesome. Take care.
All right, thank you. Bye-bye.